In this video, I'm going to show you how to evaluate logarithms using the change of base formula. So here's the change of base formula right here. It tells us that another way to express log base a of x is to choose any base b and write the fraction log base b of x over log base b of a. So the change of base formula gives us a way to convert a log of a base a to a ratio of logs of any other base b. It's just log of x over log of a, both taken with respect to some base b. Okay, so let's do some examples to see this change of base formula in action. First off, we want to express log base 3 of 5 in terms of log 10. So let's go ahead and write this down on the left-hand side. Log base 3 of 5, and we want to write that in terms of log 10. So looking at our change of base formula, that's just a ratio of two logs. It'll be, we'll choose log base 10 for both of these two logs. Log base 10 of the first one is log base 10 of the input x here. Here in this case it's 5, so log base 10 of 5, and then divided by another log base 10. 10 is what we're choosing as b, log base 10 of, this time it is the original base of logarithm, a, and a in this case is 3. So there we have it. Log base 3 of 5 can also be expressed as log base 10 of 5 divided by log base 10 of 3. There we go. Okay, next one is to express log base 15 of 2 in terms of log base 7. So now the base is going down, but the process is still the same. So let's write log base 15 of 2, and we want to use our change of base formula to write it in terms of log base 7. So change of base formula, we know we're going to have a fraction. It's going to be log over log, and we'll choose 7 for both of our bases. And now we just have to see what goes as the input to each log on top and on bottom. So on top, again, the input to this log is the input to the original log, so 2 still. And then on the bottom, the input to that log is the base of the original log, so 15. And there we have it. Log base 15 of 2 is equivalent to log base 7 of 2 divided by log base 7 of 15. Alright, here's an example. We want to use the change of base formula to evaluate log base 2 of 9 using a calculator. Why don't we start off by looking and seeing if we can just type in log base 2 of 9 on our calculator. Is there any way to do that? Well, there's a log button. Let's press the log button. Log and then parentheses. Okay, so this doesn't seem to have a base. What does that mean then? So on a calculator, if you see log, just the word log without any base, that means log base 10. 10 is the default base if the log doesn't say any base after it. It's base 10. So that means in order to evaluate log base 2 of 9 on our calculator here, we're going to have to convert it so that we can express it in terms of log base 10, so we can actually type it into the calculator using that log button. So let's just use the change of base formula to do this. So log base 2 of 9, using the change of base formula, we can write that as log base 10 of the argument to the original log, 9, divided by log base 10, gotta use the same base here, base 10, of the original base of the logarithm, which was 2. And now, since log base 10 on our calculator is just represented by the log button, we can type this into the calculator as just log of 9 over log of 2. So why don't we go ahead and do this? Log of 9, we've already got log entered, so log of 9, then divided by log of 2, and parentheses. What do we get? Our result is approximately 3.169925. Why don't we round that to 3? 3.16993. Now before we go on, let's check ourselves. If 3.16993 is log base 2 of 9, then if we raise 2 to that power, 2 to the power of 3.16993, we should get a result of 9, or at least very, very close to 9 since we rounded off a little bit. So why don't we try this on our calculator. So clear it out, and then put 2 to the power of 2 caret, and then put that number in, 3.16993, press enter, and there's our result of 9.000. Oh, it's very, very close to 9. So great. We can be sure that this is the right answer then. Now, one more thing before we go on, let's talk about natural log. So right below the log button, on this calculator at least, on other calculators it might be elsewhere, but there's a natural log button right here, ln. So ln, natural log, remember that just means log base e, where e is Euler's constant, which is approximately 2.718, so on. It's an irrational number. So another way we could have computed this logarithm on our calculator is to use the natural log and write it in terms of base e instead of base 10. Actually, why don't we go ahead and give that a shot and make sure that we get the same answer, because it should come out to the same result. So if we write it again, but this time use log base e, so log base e of 9, all over log base e of 2, then we can simplify that into just natural log of 9, ln of 9, over ln of 2, and then we should get the same result. So let's go ahead and compute that in there. So natural log ln of 9, then close parenthesis, then divided by ln of 2. And what's the result there? Well, it's exactly the same. 3.1699925, let's round it to 3. Yeah, our results are exactly the same. So when using the change of base formula to compute logarithms on the calculator, it doesn't really matter whether you use log, meaning log base 10, or natural log, meaning log base e. Either one will give you the correct result. It's just a matter of preference. So previously, we saw how the change of base formula can be used to help us evaluate logarithms using a calculator, and in this example, we'll also see how it can be used to evaluate logarithms without using a calculator. So here we want to use the change of base formula to evaluate this log base 9 of 27 without using a calculator. So why don't we write down the template for the change of base formula first. So we're starting out with log base 9 of 27, and we're going to be changing the base of that logarithm and expressing that as a ratio of two logarithms. So it'll be some log base something over log base something. The top log we know will have an input of 27, and the bottom log will have an input of 9. Okay, and let's choose some bases on the logarithms so that it's easy to compute both of these. So why don't we just leave rectangles there for now. That'll show us that we're going to be putting in bases here, but we don't know what they are just yet. So let's look at 27 and 9. Can we choose a base for both of these where it's easy to evaluate log base and then 27, and where it's also easy to evaluate log of that base of 9? Well, here, notice that 27 can be written as 3 cubed, and 9 can be written as 3 squared. They both have a common base of 3 here, raised to different powers. So that's a good indication that that common base of 3, that's what we should be using as our change of base here. So we want to change it to be base 3. So log base 3 of 27, well, that's like asking what is log base 3 of 3 to the third. And then that's going to be easy to compute, but let's write down the bottom first. Well, and then what's log base 3 of 3 squared? Well, log base 3 of 3 cubed just asks us what power do we have to raise 3 to get to 3 cubed. So clearly that's just going to be 3. That's just going to be the exponent here. So just 3 over, and then here, same idea, it's just going to be the exponent 2. So that's what log 9 of 27 is. It's just 3/2. So now we know how the change of base formula can help us evaluate logarithms both with and without using a calculator, and in the future we'll also continue learning how to use the change of base formula to simplify logarithmic expressions.